So let's see today's GLG problem of the day, search in full rotated sorted 2D matrix. So question is a bit confusing, but what question want to say that you will be given a 2D matrix. It is a kind of rotated matrix. What I'm trying to say that if suppose this number is 1 in 1D array, then it is sorted, but it is rotated by some index. So what I'm trying to say that this I have taken example from the test case given. So if we will convert this into a 1D array, then at some there will be some pivot at which it is rotated, and if we maintain see after that pivot, then it will be sorted. Like here the smallest value where it is here 1, you will see after this is sorted, and if it will come in cyclic order, then it is sorted. So it will be always like that. It will be sorted 1D array with rotated at some pivot. Now there will be given a value of x. You have to just find if x is present in not. If you want to just solve, you can just iterate and see if x is present or not, and it will be the one of the solution, but it is brute. But the given question has time complexity of log n into m. So let's see how to solve this. So this test case is from the question only, and the x value was 3. So what we can predict from the given time complexity, we have to do some kind of binary search. So how we will implement binary search? Why I am telling this? Because there is some kind of sorted array given, it is rotated, but yeah, we can apply binary search anyhow. So what I'm telling you, imagine this 2D matrix into this 1D array. Why it will always work? Because you will be in binary search, what you basically do, you will be given an array and you will be assigning left and right, and according to the value that you want to search, you move left and right. So if you imagine this into a 1D array, you can do the same thing that you do in normal binary search. Like this is not ordinary binary search. You just write a inbuilt code like find upper bound or lower bound. You have to implement manually. So let's understand. So how to do? You have assigned left and right. From this you will find the mid value. How? Left plus right by 2. So you can always map this index to original 2D matrix. How? If suppose number is 6, how you will find which element it will point in the matrix? You will just divide by the number of column it has, that is m, which you can find matrix of 0 dot size. So you just divide by m. This is a row number, because if it is 6, then it will be 1, so it will be basically here. And for the column you can just remind by m. So it will always give a particular value in a matrix, and even you can dry run. For that you will find that it will always work. You have to just divide by m and percentage by m. Now our target is to move our left and right using binary search concept. So one thing we for sure know, that there will be one pivot. If there was one pivot, then our question would be very easy, but there is a pivot, so you have to take care of this. So I am writing a binary search in such a way that this is what condition you already know. So any value will be some mid value you will always get by left plus right by 2. So the whole array will be divided in 3 parts, like 2 parts actually, left, mid and right. So one thing we for sure know, either this one or this one will be sorted for sure. You pivot either lie here, either lie here. So we'll just check which one is actually sorted. How we can check? If left value is less than equal to mid value, we will point it to the original matrix, then we will get the value of left value and mid value. Then the first half will be sorted because left value is greater than mid value. If it wasn't, because if the pivot was there, this wasn't be possible. You can just check, because it is a kind of sorted, it will either increase or decrease. So you know the first half is sorted, so you can move accordingly the left and right. And if it wasn't there, then the second half is sorted, then you can move left and right accordingly. So for your reference, you can find